apparently a number of you are having difficulty with lesson 12, which actually discusses the standard normal distribution. Um, but I want to begin by talking about just a normal distribution in general, because it is one of the most used probability distributions throughout statistics. And so it is extremely important that you understand how to work with a normal distribution. So a couple of things about a normal distribution is that a normal distribution is in a sense, it is a continuous probability distribution, or another way to think about it, which goes back to algebra, is that it is a continuous function, which means when you draw the picture of a normal distribution, you can draw the entire picture without having to lift your pen. So typically when we draw a normal distribution, we have a horizontal axis or a horizontal number line, and then we have our normal bell-shaped curve. And again, you'll notice I was able to draw the entire curve without lifting my pen. Secondly, the normal distribution is symmetric about the mean, meaning that the mean is a measure of center. So it would be in the center of our graph. Okay, and so the left side of the curve is a mirror image of the right side and vice versa. That's the idea that it's symmetric. If we could pick this curve up and fold it across that dotted line, which is the mean, then it would be, you couldn't tell the left side from the right side. And the other characteristic that's important is that it has that bell shape, that it's bell-shaped. The shape, now I drew it, kind of what you would normally see, but the shape of the normal distribution is actually determined by two different measurements or two parameters. And those two parameters are the mean of the distribution and the standard deviation of the distribution. And so you can actually use any value that you can possibly think of for the mean and any value you can possibly think of for the standard deviation except 0. So when you have an infinite number of choices for the mean and an infinite number of choices for the standard deviation, and you can do that in any combination, you have an infinite number of normal distributions. And so statisticians kept running up against that issue that they had, all these different standard deviations. And one way to solve the problems is to do calculus, which probably none of you want to do. So mathematicians, before we had the technology, had to come up with some way to not have to do calculus all the time. So before the advent of calculators and computers, oftentimes to solve problems related to the normal distribution, we used a table. And so that they didn't have to create a table for every possible combination of a value for the mean and a value for the standard deviation, they standardized it. They kind of created a standard normal distribution, and then they created the table using those particular values. And so everything had to relate back to that standard normal distribution. For the standard normal distribution, your mean is 0 and the standard deviation is 1 every time, all the time. So that visually, and I may have run out of space here. Let me see if I can. No, I can maybe squeeze it in right here. So if you're looking at a picture of your normal distribution, you would have the horizontal axis, your bell-shaped symmetric curve, the mean, which is the measure of center, would be 0 and your standard deviation would be 1. And then we measure the units on this number line correspond to the number of standard deviations that you are above or below the mean, which relates back to the z-score that you talked about earlier. So when you deal with the standard normal distribution, most everything is stated in relationship to a z-score. So I would have 1 standard deviation above the mean, so the z would be 1. 2 standard deviations above the mean, the z would be 2. 3 standard deviations above the mean, so z would be 3. If I'm below, those z values become negative. And we applied the empirical rule to this bell-shaped symmetric distribution earlier. So if you had a z-score of exactly 1 or exactly 2 or exactly 3, then we could apply the empirical rule. But if we take a look at this first question here, that says find the area of the shaded region where A equals negative 1.03. Note the graph may not be drawn to scale. Okay, so one other thing that I need to mention, and I do not know if they mentioned it in the lesson, all these questions talk about finding the area of the shaded region or the area under the curve. What you may not know or have understood is that the area under the curve corresponds to the probability. That's the connection between the normal distribution and the idea of finding a probability, is that area under the curve corresponds to the probability. And so really they're just asking you to do some calculations. Now they really kind of make it sound difficult, okay? But this question says find the area of the shaded region where A is negative 1.3. Now I have to assume, since this particular question is in lesson 12, which is about the standard normal distribution, I have to assume that this drawing is a drawing of the standard normal distribution, and that my mean, by definition, the mean is 0 and the standard deviation is 1. And I don't particularly care for this drawing that they've done because they didn't label the mean. Okay, normally with a normal distribution, you would label the mean, and our mean in this case is 0. But we want to find the area of this shaded region. And so I'm going to be able, it's a normal distribution, so I'm going to use my calculator. Now again, if I were doing this in olden days, I would have had to do a table. But since I have the calculator, and guys, the command is normal CDF. You always use the CDF because you want the cumulative. We want the area beginning at negative 1.03 all the way up to the end. Now, the other thing you need to understand is that this curve is continuous, meaning it keeps going on and on and on and on. Although it looks like it actually touches your horizontal number line, it really never does. So this technically, theoretically, goes all the way out to infinity. It keeps going and going and going. And so the drawing hopefully will help you know what to enter, because when this normal CDF command, you enter the lower limit or your lowest value. Then you enter your upper limit or your highest value you're interested in. You enter the mean and the standard deviation. So for this problem, which again, it doesn't specifically state that it's a standard normal, but assuming it's in that section, so we're going to type normal CDF. We would enter negative 1.03 to positive infinity. And I know that the extra notes on lesson 12 under the discussions show you how to enter infinity. It's 1E99, and I'll show it to you on the calculator in a minute. The standard deviation, the mean is zero, and the standard deviation is 1. Okay, so I'm going to go out and I'm going to type that into my calculator. Okay, to get to the distribution list, if you'll look next to the clear button, there is a calculator button that says VARS, VARS. Above it in blue, you should see DISTR, which is the abbreviation for distribution. It's in blue, so we press the blue second button, and then the VARS, and I need the normal CDF, which is option 2. And then it asks me for the lower, where are you going to begin? It asks me for the upper, the mean, the standard deviation. Okay, so my lower, we work left to right, so we have negative 1.03. My upper is positive infinity, so we press the number 1, then we press the second button and comma, and that E pops up, and then I enter 99. What I'm really entering is 1 times 10 to the 99th power. So you're thinking it's a 1 followed by 99 zeros. That's the biggest number that we can enter into the calculator. The mean is 0, standard deviation is 1, and I'm going to paste and enter. And it gives me the calculation. It does the calculus behind the scenes and does it for me. So I have 0.84849. We round to 4 places, so it's going to be 0.8485. So the area that's shaded is 0.8485, which is also the probability that you would get a value for Z that is greater than negative 1.03. Okay, I'm moving on to the next one. Again, we're still assuming that it is a normal distribution or a standard normal distribution. Okay, so again, because we believe we're dealing with the standard normal distribution. Okay, so our mean is 0 and the standard deviation is 1. And then it says find the area of the shaded region where A is negative 1.81 and B is 1.87. And there's 2 different ways to do this problem, because if you'll notice, you have 2 different regions. Okay, you have 2 different regions, and again, we want to know this from negative 1.81 to the left. And again, because it's a continuous function, it keeps going on forever and ever and ever and ever in that negative direction. So it actually goes to negative infinity. The other way, 1.87, the shaded region is to the right, and again, it keeps going forever and ever and ever and ever to positive infinity. Now again, there's 2 different ways to work this problem. The easiest way is just to think about it logically. I need to figure the area of the region on the left, and I need to find the area on the right. and then I'm going to add them together because I have two different regions and I want to have the answer include both of them. So here's what I would type. I would type normal CDF. Starting at the left, we would go from negative infinity to negative 1.81, mean of 0, standard deviation of 1. That gets me the left side, plus, and then I have to do the right side. So I would have normal CDF beginning at 1.87 going to positive infinity, mean of 0, standard deviation of 1. I'm figuring each individual region and I'm going to combine them together by addition. But the calculator will do all of that at one time. Okay, so here we go. Second vars, normal CDF is option 2. For the left region, I need negative infinity, so it's negative 1, second, comma, 99, 2, negative 1 point, let me double check my number, 81, negative 1.81, mean of 0, standard deviation of 1, and I paste. Then I'm going to add. And I do second vars, normal CDF. I begin at 1.87. I go to positive infinity, so it's 1, second, comma, 99, mean of 0, standard deviation of 1, paste. So now I have the second piece, and I enter. And we get a value of 0.06588. So when it rounds to 4 places, it's going to be 0.0659. Okay, so that corresponds, again, what we've calculated is the area of these two regions together. It combined it together for me because of the way that I typed it in. So it corresponds to the area, but it also corresponds to the probability. Okay, I think some of you guys maybe are overthinking it. Okay, so just take your time and walk through it. It really is somewhat common sense if you'll pay attention. Okay, so the third one here says the area of the shaded region where A is negative 1.72 and B is 2.12. Okay, so here again, you have the standard normal distribution. It doesn't say that, but again, we're in that particular lesson. Mean is 0, standard deviation is 1. Again, I don't like the fact that they don't label the mean, okay, to give you a point of reference. So this is a between. It actually gives you a beginning point and an ending point. So we would type normal CDF left to right. So my lower limit is negative 1.72 to 2.12. My mean is 0. Standard deviation is 1. Type it in the calculator. So we do second vars, option 2, normal CDF. We're beginning at negative 1.72. Whoops. Have a 7.2. Let me double check my number. Yep. My upper is now 2.12 because it gives me a beginning number and an ending number. Mean is 0. Standard deviation is 1. Paste. and enter. And I get 0.94028. Again, when you round, you're going to get 0.9403. And again, that corresponds to the area of the shaded region, but it also corresponds to the probability that you would have a z-score between negative 1.72 and 2.12. Okay, so then this question, number 4, it actually specifies for us that we have the standard normal curve. When I see that phrase, I know automatically that my mean is 0 and my standard deviation is 1 all the time, every time. And it says between negative 1.51 and 1.98. Okay, I like to draw the picture because the picture helps me to see what I should enter into my calculator. So I have my horizontal number line, my bell-shaped curve, and I always label the mean, which is the measure of center in the middle, and it is 0. A z-value of negative 1.51, because it is negative, would be below the mean. So this would be z equals negative 1.51. I'm just estimating where it's located. And then 1.98, which is positive, a positive z would be to the right. So z is 1.98. They went to using z's instead of a's and b's. And it says we want the area between those two numbers. So in terms of the shaded region, or the region that I'm looking for, it would be this one right here. So again, it's a between. I'm still going to use my normal CDF command. So I have normal CDF beginning at the left with negative 1.51, going to the value on the right of 1.98. Mean is 0. Standard deviation is 1. Okay, so here we go. Second, vars, option 2, my lower is negative 1.51. The upper is 1.98. Whoops. The mean is 0. Standard deviation is 1. We're going to paste. We get 0.91062. So I will not round up. So it's 9106. And again, that corresponds to this red shaded region. It also corresponds to the probability that we would have a z-score between negative 1.51 and 1.98. The next question says, find the area under the standard normal curve. So again, the first thing that jumps out at me is we want standard normal curve. So that tells me that my mean is 0 and standard deviation is 1. That's the definition. So that will always be the case when you're dealing with the standard normal. So if I start drawing my picture, I know I have my horizontal number line, my bell-shaped curve. The mean is the measure of center and is in the middle and becomes my point of reference. And then it says we want to be to the left of z equals negative 0.71. Okay, it's negative, so it's going to, that value of z is going to be to the left of the mean. So z is negative 0.71, and you want to be to the left of that. So if this is my point of reference, the left would be this area here. And again, remember, technically this does go out to negative infinity because it is a continuous curve. It keeps going and going and going. So we would type normal CDF from negative infinity to negative 0.71, mean of 0, standard deviation of 1. Now, you're not required to draw the picture, but I like to draw the picture because it helps me to see exactly what I need to put in the calculator. So we go to second, vars, option 2, normal CDF. I'm going from negative infinity, so negative 1. Whoops, I missed my negative sign there, guys. Negative 1, second, comma, 99, up to negative 0.71, mean is 0, standard deviation is 1, and we paste and enter. We get 0.23885, so we do need to round up, so it's 0.2389. And again, that corresponds to this red shaded region to the left of negative 0.71. And to the probability that we would have a z-score less than negative 0.71. Okay. This one says find the area of the standard normal curve to the right of negative 2.37. Guys, you have to be really careful reading these questions. Okay, you got to catch all of the words. Again, the fact that it says standard normal curve, I know automatically by definition the mean is 0. Whoops. The mean is 0 and the standard deviation is 1. So if I start drawing my curve, I have my horizontal axis, my bell-shaped distribution. The mean is in the middle, which is 0. Then it says to the right of negative 2.37. So again, being negative, your z-score is going to be to the left of the mean. So this would be z equals negative 2.37, and you want to be to the right of that. So you're really looking for this big shaded region on the right-hand side of this curve. And again, remember, this curve is continuous and it keeps going in the positive direction, so it goes to positive infinity. But guys, if you're reading too fast, you're liable to miss some of those key important words. So we would type into our calculator normal CDF from negative 2.37 to positive infinity, mean is 0, standard deviation is 1. Second, vars, normal CDF, my lower is negative 2.37. I'm sorry, my negative sign didn't go in there. Negative 2.37 to positive infinity, 1 second, comma, 99, mean is 0, standard deviation is 1, paste, enter. We get 0.9911, 0, and it keeps going. Okay, so, sorry about that. I get 0.9911. So the probability that I get a z-score greater or to the right of negative 2.37 is 0.9911. Okay, going through this one, it says find the area under the standard normal curve. Again, standard normal curve, mean is 0, standard deviation is 1. Okay, so we have a horizontal axis, our bell-shaped distribution. The mean is in the middle, which is 0. And it says that lies outside the interval between negative 2.49. Okay, so since it's negative, that would be here on the left. Z is negative 2.49 and positive 2.14. So positive 2.14 would be on the right, and it wants us to be outside that, not between. So outside implies that I'm in this region to the left and this region to the right. The one on the left continues to the left to negative infinity. The one on the right continues to positive infinity. So again, because of the outside, you have two different regions. So this is the case where you have to add the two regions together. So we would have normal CDF from negative infinity to negative 2.49, mean is 0, standard deviation is 1. That gets us the left side, plus, and then we get the right side. Normal CDF from 2.14 to positive infinity, mean is 0, standard deviation of 1. Put it in the calculator. All right, so we do second, bars, normal CDF option 2. We go from negative 1 second, comma, 99 to, and let me double check the number, negative 2.49, negative 2.49, mean is 0, standard deviation is 1. We paste, then we add second, vars, normal CDF, let me double check the number, 2.14. Okay, so we go back to lower is 2.14, upper is positive infinity, so that's 1 second, comma, 99, mean is 0, standard deviation is 1, paste, enter, and it's going to do the two calculations together. 0.02256, so when we round, it's going to be 0.0226. So this equals 0.0226. And again, the calculator adds the two regions together for you. All right, now we're going to switch gears a little bit. Okay, because now it says the z-scores that bound the middle 70% under the standard normal curve are z equals negative a and z equals positive a, and it wants you to find the value of a. Now we're kind of, in a sense, working backwards because they're going to tell me the area that's under the curve, and we need to find the z-scores. So this is a different type problem. When you're given the percentage, we use a different command. This is what we call, the inverse normal. distribution, because we start out knowing the percentage or the probability or the area under the curve. Now, this one's a little tricky, okay, because it's wanting you to do the middle 70%. So let's see if we can kind of sketch a picture here, okay? So we know we have a normal distribution. It is a bell-shaped curve, and it's the standard normal. So my mean is in the middle, which is 0, and my standard deviation would be 1. And we want to find the middle 50%. Okay, so here the mean is our measure of center. Okay, it is symmetric, so it divides the entire curve so that there's a full 50% below and a full 50% above. But I want to know what's in the middle. So 70, if I divided it in half, since my curve is symmetric, half of 70 is 35%. So I'm going to have 35% below the mean and 35% above the mean, which gives me a total that corresponds to the middle 70%. And it tells me that I should have a value for z that's negative and a value for z that is positive. Now they're calling it A. Okay. And again, we could do some work on a table and all that kind of stuff, but we have a calculator command that will do it for us. It is the command inverse norm. Okay, and here's the key part. This is where it gets a little tricky, because the command is you want the area to the left every time, all the time, but that is not necessarily the area that you're given. So that's where it gets a little tricky. Okay, for the inverse norm distribution, you want to enter the area to the left, okay, the mean, and then the standard deviation. So I need to think about this for a minute. Okay, and hopefully this will make sense to you. Again, this whole half, we have a total of 50% below the mean and 50% above the mean. Okay, the mean is my dividing line. So if I have 50% over here and I'm taking up or using 35%, that means out here in this little tail or that little region on the end, I'm going to have 50% minus 35%, which is 15%. Now we do like to write that as a decimal. Okay, so 15% as a decimal would be 0.15. So that's the area. If this negative z is my cutoff score, the area to the left is that 15%. Okay, so we would do inverse norm, 0.15, mean of 0, standard deviation of 1. Now I know it's a little tricky here, guys, but this is the way that the calculator is programmed. You have to give it the area to the left. Okay, this just happened to be the next question in line in the assignment, so that's why but to me it's kind of a hard one to start with. Okay, so to get your inverse norm, you still do second vars, and now it is option number 3. And it wants the area. It doesn't specify to the left, but that's how the calculator is programmed. So we want 0.15. Mean is 0, standard deviation is 1. I'm going to paste and then paste again, and I get negative 1.036. We round z-scores to 2 places every time, all the time. So this is negative 1.04. Make sure okay. Now again, because it's symmetric, that should mean that this upper one is positive 1.04. Okay, but let's double check it. Okay, but now here again, guys, be super duper careful. Okay, because again, you want the area to the left. So let's think about it. To the left of this positive number, I would have 35, 35, and 15. So that's 35 and 35 is 70, plus the 15 would be 85. Okay, so this is going to be, and let me change colors here. For this upper one, we have to use 85%. We have to do 35, 35, and 15. Okay, because it's always the area to the left. So you would do inverse norm. This time you're going to put in 85%, 0, and 1. So second vars, option 3, 0.85 is the area, mean is 0, standard deviation is 1, paste, enter. And guys, notice we get the same answer that we got a while ago, but it's positive. And we should, because this curve is symmetric, it should be the same number. One of them will be positive, one of them will be negative. And it even implies that in the question, because it says find the value of A, and it indicates that the A can be negative or it can be positive. Okay, so just be careful, guys. You got to pay attention to the wording. All right, a couple more of the inverse normal. Okay, so this one says find the z-score for which the area to the right is 0.71. Okay, so again, in this particular problem, I'm given the area to start with, and I know that I have, it doesn't specify, but I can assume I have a standard normal distribution. So my mean is 0, the standard deviation is 1, and I have an area to the right is 0.71. Now guys, you got to be super duper careful here because it says area to the right is 0.71. Well, guys, that's less than 1%. So I'm really going to be somewhere up here to the right. This little red shaded region is an area of 0.71. Okay? But in order to type it into the calculator, I need the area to the left. Now I know this whole curve is 100%. So 100% or one whole minus 0.71. And I'm sorry, I don't have that drawn right. Okay, that's my fault. I'm sorry. Let me fix it. Let me start over. Miss Ralston got it a little mixed up. Okay. I'm entitled to one mistake. All right, so it's still the area to the right. I just got it shaded wrong. Okay, mean is 0, but 50% to the left, 50% to the right. So there's 50% up here. So if I need 0.71, my cutoff should have been over here. I'm sorry, it was my fault. Okay, so 0.71, the area to the right. So way up here, all this area up to the right is 0.71. And so still the issue is we need the area to the left. Okay, area to the left. And I can find that by doing one whole, 100%, minus 0.71, which is 0.29. And this is the value that I need for inputting into the calculator, because you need to input area to the left. So we do inverse norm. Area to the left is 0.29, mean is 0, standard deviation is 1. And again, the way this picture is drawn, it doesn't indicate so in the question, but now that I have it drawn correctly, I can see that my z-score most likely is going to be negative because I'm below the mean. So let's see. We would have second, vars, inverse norm is option 3, area to the left is 0.29, mean is 0, standard deviation is 1. We're going to paste. We get negative 0.55338. Again, z-scores are rounded to 2 places. So this would be, my z-score would be negative 0.55. And again, it really helps you to draw the picture and to draw it correctly. Again, I did make a mistake, so I got it corrected though. All right, this one says find the z-score for which the area to its right is 0.36. Okay, so we have our horizontal axis. Again, it doesn't specify, but I'm assuming we're dealing with the standard normal. The mean is 0. And again, remember, in terms of this whole curve, remember that you have 50% below, which is 0.5, and 50% above, which is 0.5. And this number, 0.36, and it says to the right. So this time, I think I can get it correct the first time. Okay, so I would have 0.36 in this tail to the right, and 0.36 is I'm not below. Okay, but again, because that gives us the area to the right, you need the area to the left. Area to the left. And so I can do 1 minus 0.36, which is 0.64. So the area to the left is 0.64, and that's important because that's what you need to enter into the calculator. Inverse norm, 0.64, mean is 0, standard deviation is 1. And again, what I can see from my picture is that my response or my answer should be positive. So second, vars, option 3, I have 0.64, mean is 0, standard deviation of 1, paste, enter, and I get 0.358. When I round that to 2 decimal places, it becomes 0.36. So my z-score is 0.36. I hope that this will help you in your understanding of the normal distribution. In lesson 13, the difference is that you will be given a specific value for the mean and a specific value for the standard deviation. The problems work the same way, but you use the mean that you're given and the standard deviation that you're given. But the commands in the calculator are the same.